today we're just going to kind of talk about the basics of what an Arduino is, make sure everyone's installed. If we go relatively quick, which we might jump to the next lesson, which is about kind of the basics of inputs and outputs. As you may know, kind of the general idea is to get a feel for how Arduino works, be able to do a little bit of programming, also be able to do basic circuit design and circuit building and testing on like breadboards. And the goal at the end of this would be, as some people may know about the Tiny Cart project, what's your name again? Brett. Sorry. Will and Brett, do you know what the Tiny Cart is? Okay. Basically a little autonomous race car that will have a lot of high-level processing, but it will have several sensors communicating to an Arduino that will then communicate that information to our main processor, the NUC. So hopefully by the end of this, everyone here will be able to know how to design the circuits and write the code for that Arduino to handle all that sensor processing. So what is an Arduino? An Arduino is basically an open source microcontroller. The open source means that basically the designs are online. Anyone can make one up, which is why you'll find a lot of Chinese knockoffs. But they're relatively cheap. They're very easy to use. They're great for learning. If you're going to use a microcontroller in like a work environment, a real-world environment, you probably want to use a better one. But for educational stuff, for research stuff, they're really great. Code is kind of a weird, simplified C++. And then kind of what an Arduino does, but also what microcontrollers do in general, is they take in inputs, they process that, and then they turn on or off certain outputs. So kind of a good example of the difference between a microcontroller and a processor is kind of what I was just talking about with the Tiny Cart. You'll have the Arduino, and then you'll also have an onboard NUC, which is basically like a small computer. And so the Arduino is going to be reading low-level sensors and dealing a lot with that actual hardware, turning things on and off, while the NUC is going to be handling a much higher computational load, but it's not going to be dealing directly with hardware. Another thing is normally like a microcontroller is kind of designed for a single use, and that's not really true with the Arduino, but like a dishwasher may have an Arduino put in, or a microcontroller put in, and it has one job. When you push a certain combination of buttons, it turns on water for certain time limits. But like a computer, which would be a processor, is much more, you can do a lot more with it. It's a word processor, you can also check your email, you can run high-level code on it. So that's kind of the general difference between a processor and a microcontroller. An Arduino would be an example of a microcontroller. A Raspberry Pi would be an example of like a processor that's kind of compatible. It's cheap, used for educational use. So here is a picture of an Arduino. You may have seen this before. Just some basic things to point out. This is the USB port, so you'll plug in from your computer a cable, then plugs in here. It'll power it. It'll also transmit data when you write code. You can also power it from a DC power jack. I believe you need to power it with 9 volts here. Reset button. And then as you see, there's lots of inputs and outputs along the side. And a lot of these pins have many different uses. You can kind of configure it depending on your need. Can you see this okay? I guess you can probably read it off my computer, yeah. So now we're going to talk about a couple electrical basics. This is going to go relatively quick unless anyone has any questions, but don't be afraid to ask any questions. Before I talk about binary, real quick, probably most of you know there are analog signals and there are digital signals. Digital signals are basically, there's two states, on or off, 0 or 1. But analog signals, there's a range. It could theoretically be like negative infinity to infinity, or maybe if you have a sensor that uses 5 volts, the range is going to be in between 0 and 5 volts. But there could theoretically be an infinite number of different possibilities between 0 and 5. There could be 1 volt, there could be 1.11 volt, 1.111 volt. So you can see that difference over here. So when we build our computer, or build a microcontroller in this instance, the microcontroller handles data through digital signals, through zeros and ones. There's a lot of transistors on board that are basically switches. They're either on or off, and that's how the Arduino processes data. So because we basically have zeros and ones for our numeric system, we only have 2 digits, and that means instead of using decimal, the microcontroller, or the same way with a computer, is going to store numbers as binary numbers. Any questions about that? Okay. And then, so because microcontrollers or computers can only handle digital signals, as you can see here, a lot of times in the real world we'll have a sensor that's measuring an analog signal, because most things in the real world are analog, like how much light is in a room, the sound level, those things all vary. It's not either 0 or 1. So when a sensor measures that and then it outputs it to the Arduino has to find a way to convert that analog signal into a digital signal, which is the basics of signal processing, which can get pretty complicated. But in a simple form, you got your analog signal here, you sample it at a certain rate, so you don't read every single voltage reading coming in at every single time instance. You maybe do a reading 10 times a second, 100 times a second, and then you also quantize the signal. So maybe if you only had 5 readings and the signal is between 0 and 5 volts, then you'll just round to the nearest volt. 0 volts, 1 volt, 2 volt. Obviously in our system we're going to be a lot more precise than that. But so this is how you can take an analog signal and put it into a digital signal, and then the microcontroller would be able to handle that and process it. Ohm's law. Has anyone not heard of Ohm's law before? Okay. So Ohm's law, there's volts, current, resistance. They're all measured together in V equals IR. Skip that for now. Okay, so some coding basics. Like I said before, Arduino code is simplified C++. The code is compiled into assembly, then compiled into machine level code. Every code is going to have these 2 sections, this void setup and this void loop. The setup is only going to run once, so this is where you kind of set up what each pin is going to do on the Arduino, whether it's an input, whether it's an output, and it's just going to run once, and then the loop is going to be the code that's going to run forever. In our example, we're going to blink an LED, so in this part, it's going to be the actual blinking part. If you're curious, this would be kind of an example of this high-level code. It's very easy to read, or high-level language. C, C++ would be an example of that. This would get converted into assembly language, which you can still kind of read as a human, but this gets a lot more down to the hardware. Like this specific hardware register has this specific value. It's going to transmit that to this register. So it's a lot harder to read. And the machine language is what the Arduino actually quote-unquote reads, which is all zeros and ones and impossible for us. But it's a lot easier to deal with this and then have it compiled and assembled into the stuff the Arduino will actually use. So now we're going to start with the blink example. This might be really easy for all you guys, but we'll just do it anyway. So in the kits, if you want to get out the Arduino and the breadboard, hopefully there's some wires in there. Hopefully there's a resistor in there. Probably a lot of you guys have worked with a breadboard before, but if you haven't, this is what it looks like. Ta-da! When you're connecting things, these horizontal holes are linked together. So you plug in 2 wires in the same horizontal place, they are electrically connected together. But if you connected them like one here and one here, that would be electrically isolated. Also, there's this bridge, this middle divider in the center, so this and this are both on the same horizontal row, but they're not connected electrically. Also, these vertical rows along the side are connected, and that's typically used for your voltage and your ground, just because then you have a lot more pins to connect to it. Normally that's the place that you make the most connections to. So if everyone wants to wire this up,
but then you could change the numbers
yeah,
and make it do different
yeah,
things.
you can.
Craziness.
You figured out coding.
The serial port is still not selected, and I don't know how to select.
Oh, okay.
Yeah.
So once you have this coded, and you go to the Arduino sketch, to actually upload it, you'll need to go to Tools, and then on this port, well, first you should go to Board.
I think after you do this, it automatically.
Here, Zach. When you're all done, if you go to Tools and then Board, and then Arduino boards, then you should be able to select Arduino Uno.
Yep.
And then once you've done that, you can go to Port, and whatever port is available is the port you're connected to. If there's more than one, let me know, but there should just be one.
There's only one.
Okay.
Thank you.
Yes, and then once you've selected that in the bottom corner, way down here, you should be able to see the values you selected. And then you should be able to verify and upload. And if you hit verify and something went wrong, that means you have a coding syntax error. Well, so with this code, if we just want to step through and see what each part does, as we mentioned before, there's a setup and there's a loop. Setup runs once and it kind of sets up all the variables. So here is where you use kind of an Arduino predefined function that's called pin mode, where you give it a number and then a value, I guess. So in this instance, we're making 13, pin 13, be an output. Later, if we work with inputs, we would make this be an input. Just type input in all caps. And then in our loop is where we actually execute the code that repeats forever. So there's also this Arduino predefined digital write function where we pass in a pin number and then we pass on what we want to do with it. So right now, since we're just using digital, that's a digital signal, so it's either high or low. So we're going to type in high, all caps, and there's a delay, which we can set that delay to be at whatever we want, and this is in milliseconds. So 1,000 milliseconds is 1 second. Then we do digital write 13 low, and then also do a delay of 1,000. If hopefully you all are familiar with this, with like the semicolons at the end of each statement, that's just standard C. With 2 slashes, that's a comment. But yeah, that's our basic Blink code. Variables, so in here we didn't use any variables. But if we wanted to set up a variable, this is basically just a name that stores a value that then makes it easier when we code. So instead of saying 13, we could say LED, like LED pin or LED, and we could set that equal to 13, and then everywhere in our code we can use LED pin, and that makes it easier to read. If you're reading through the code and you read 13, you might not know what that means, but if you read LED pin, okay, I know what it's turning on. Also, if you suddenly had to change to pin 12 for some reason, you'd have to, if you didn't use variables, you have to go through the whole code, and every time there's a 13, write a 12. It's a lot easier if there's just at one place you have to change to 12. So with variables, there's global variables, which are defined before the setup. So anything defined up here is a global variable. You can use it anywhere in your code. Local variables are defined inside a function and can only be used within that function. We'll get to that when we get to functions. So here's another example. You could create a variable that is the delay time. So instead of just putting in 1,000, you could put in delay time, and at the top of your code you could say int delay time equals 500, or then later if you want to change it, you could say equals 1,000 equals 10,000. It's very easy to change in one spot. You'll notice that when we define a variable, we have to give it this data type. That's at the very beginning. These are a bunch of data types. I believe they're all supported in Arduino. Boolean is just true or false. A byte can be a value in between 0 and 255. A character will hold like an ASCII character, and ASCII characters are just the standard A through Z and some other characters, and it'll hold it as a number, but then the computers or the microcontroller is smart enough to recognize if it's a char character, then it converts that number into the actual character. I don't think I put an ASCII chart. So here's the rest of these. Most of the time we worked with int, which is 16 bits. If for some reason you didn't want the number to be negative, so you wanted to increase the size of the number but it not allowed to be negative, you could do unsigned int. If you're dealing with time, that's going to be a very large value, so you might want to do long or unsigned long, so you can deal with very high numbers, like if you're keeping track of the milliseconds that passed in your code. Data types. Then, I mean, you guys all said that you're familiar with if, for, if, and while statements, so we might not do this, because I go through here, talk about how you'd write an if statement, how you'd write a for statement, how you write a while loop. But maybe it'd be good practice to write it out anyway, for people who aren't super familiar with Arduino. So, in this example, we're going to create a variable that's called LED and set it to 13. Arduino also allows you to do this hashtag define, and it'll always be 13. It's more efficient for memory, but you don't have to do this if this just seems weird to you. And then we're also going to select this, or write this variable called delay time and long delay as integers. So if you guys want to do that in the code right now.
Just to clarify real quick, you had byte and word on the data types. Are those actually keywords in Arduino? Because those aren't in C as far as I know. I haven't used a lot of C, but I don't see at least don't exist.
I know byte is. I don't think I've ever used word.
Oh, so it probably is. Okay, that's really cool, actually.
Yeah. That's what I called them. Then in our setup, we're only going to do a single thing. Just like last time, we're going to do the pin mode, except this time, instead of putting in 13, we can put in LED, because the code associates LED with 13. So we'll type that in. And then in our main loop, we're going to do an if loop, or if, I don't know why I said if loop, it's going to be if statement. And the idea of this code is that we're going to have the LED blink at the normal rate 5 times, and then it's going to, I think, turn off and wait a long delay period, and then repeat the same cycle. So yeah, just as I said before, the point of this is all in your main loop. The point is to have the LED blink the normal speed 5 times, and then wait the long period, and then blink 5 times again, and just continue that on forever. Now, if at the very top in your main loop you said int count is equal to 0, and then it ran through this code and then jumped back to the top, it would see int count equals 0 and set count equal to 0 again, which isn't what we want. We want count to increase, because at the very end we put count equals count plus 1. So the way we can get around this is say static int, which means it's defined the very first time you write it, but when it sees this statement again, it's going to recognize, no wait, I've already done this. I don't have to set it equal to 0 again. But we do have to define it somewhere in the code, so that's why we do it at the very top. We could accomplish this by putting it outside as a global variable, but this is better practice to limit the variables to the pieces of code that actually use it, or the functions that actually use it. And then, since everyone's dealt with an if statement before, you'll notice at the very bottom it says if count is greater than or equal to 5, you do something. And so the first 4 times this is going to be false, and the part inside these curly brackets isn't going to happen. And because it's a loop, it's just going to jump back and do this part again. And then it's also important that while you're inside this if statement, you set count back equal to 0, because if you didn't, you jump back and this if statement would be correct. Because count would be 5, you jump back up, you go here, count would equal 6. You'd set here, is count greater than or equal to 5? It is. So then this is going to run again, and that's not the way we want our logic to work in this example.
So, I don't know if you mentioned, but what would happen if we didn't have static in front of the int?
Yeah, so we didn't, if this was just a normal int, then every time the Arduino ran this line of code, it would set count equal to 0.
Oh, so it just says it the first time?
Yes, yeah. So with static, it only happens the first time it calls it. If you got this working and this seems too easy and you want to move on to see if you can implement the same logic in a for loop, go ahead with that. And I'll show how to do it in a second. Okay, so if anyone's curious how this works, let me know. But basically, as you can see, the same logic that we use with an if statement, it's a lot more condensed in a for statement, or a for loop. And this use case is kind of exactly what a for loop is designed to do. You want to iterate over a process a certain number of times. So you create the variable, you say as long as it's under the certain condition, you're going to stay in the loop, and then also set how that variable changes each loop cycle. So yeah. And then the last one is the while loop. So if you want to try to implement it using a while loop, go ahead. I'll put the code up on the screen.
So,
What?
what's the difference between a while loop and a for?
We'll see in a second. A while loop, you give a condition, and as long as this condition is satisfied, you're going to stay in the loop.
Did we
So,
do that?
How much is left?
so with the for loop, it's kind of more condensed because there is this condition that you stay in the loop, but you also change every time. With the while loop, you don't. So with the while loop, you actually have to, at the bottom, say count plus plus. In the for loop, you don't have to put that because you'll do that up here automatically. So a better use case for the while loop would be like some variable that's changed elsewhere in the code. Maybe like while button press equals 0, do this. But then when you press the button, that while loop will be 1, so then you won't do what's in the while loop. But you don't know when that's going to happen, so you just have to put this and stay in the loop until the person presses the button.
Okay.
The for loop, so yeah, it's kind of bad to use it in this use case. You would always use a for loop in this case, but I'm just kind of, this is a good way to introduce all three of them. So as you may have heard me explain to Laura, the while loop isn't the best use case in this scenario. Like I said before, the for loop is perfect for this scenario. A while loop is much better when you're waiting on a condition to change, but you don't know when it's going to change. And a lot of times it could be like a user input. So my example was like a push button. While the push button equals 0, which means it's not pressed, do something. But as soon as the user presses the button and it loops through to that state, then okay, now that the push button's pressed, we're not going to run this code. We're going to jump ahead. So that's primarily when you'd use a while condition in Arduino. Another handy little thing, if you ever put while 1, that means it's just going to run that condition all the time. And then if in these brackets you didn't put any code, it would just do nothing forever. So if you ever want your Arduino to just run once or to have some sort of end state, you can put while one and then empty brackets just at the end of your code, and then the Arduino will only run once, and then just stay in this while loop forever, not doing anything. So
Is there a true and false?
yeah, you could also do while true. Yeah, and I guess that's a good thing to point out. So to satisfy this while condition, it's a true value, but it also Arduino also associates 1 or any value that's not 0 as true, and any value that's 0 as false. So in this case, if count is less than 5, this is a logical comparison. It's either going to be true or false. But if for some reason you just put count in here, while count, as long as count's greater than 0, this condition's true. So just be careful when you're coding that. So that's all I have for today. Next week, next Tuesday, we'll talk a little bit more about inputs and outputs, some of the stuff you can do with that. We'll mess a little bit more with some of this cool hardware and how you wire it. If you want any practice with Arduino, you're welcome to, if you have an Arduino at home, just use that or use it through Tinkercad. I think if I go here, just go to circuits, I can create new circuit, and then I can select like an Arduino, select a breadboard, drag some wires. It's pretty easy to use, as I can't drag this wire.
I think you have to click it from the ends.
It's easy to use, I promise. Maybe you have to do it before you, I think that's what you have to do. There you go.
Oh, you did it backwards.
Which one's positive? Which one's negative?
I think you can right click and change the colors.
Oh, there's little
Oh, okay.
numbers.
Maybe they changed it since I was...
Oh, that's so
What's the problem?
It's positive.
These are just arbitrary. They can be whatever you want them to be.
I just realized the positive, the red to negative.
But yeah, like I said, you can change. You can edit things in here. There's lots of components in here. If you just wanted to grab a resistor and grab an LED, and then test just basic Arduino code, turning it on and off with for loops, while loops, things like that, you're welcome to do that. And then next week, we'll talk about a little bit more about inputs and outputs.